following Paul McWhorter's Arduino Uno R4 Wi-Fi lessons, and I think it was about 14 months ago, I watched his lesson number 28, which was all about using the LED matrix. He was using bitmaps and then the Arduino graphics library, but there's an awful lot more that you can do with it. So I played around with things, and I meant to make a video, but somehow I stupidly managed to overwrite my program, and I hadn't got round to redoing it until now. Now, the reason why I wanted to remind myself about what I'd done is because of the advent of the Arduino Q, because that also has an LED matrix. It's slightly different. I haven't got a Q yet, and in order to get started with the Arduino App Lab and have a look at things, you need to have the Arduino Q connected. So I don't exactly know how it will work, but it can't be that different, I wouldn't have thought. Apart from the Q matrix has 8 rows and 13 columns of LEDs as opposed to 12 columns on the R4, which seems a bit strange to me, because 12 times 8 is 96, which can be stored in 3 times 32 bits, which seems incredibly useful. So adding just an extra LED to each row perhaps is a mistake, but what would I know? So I will start my demo now. Now here's a very simple program for displaying an image on your LED matrix. So I've just got a bitmap here with all the ones and zeros, and then you just do the matrix.And bitmap, and that is a 9 instead of an 8 because you can have another value at the end, but it's optional. So if I just run that, there you can see there's a nice heart. But what I don't like about this is that is 96 bytes to store that image, and as it's all ones and zeros, you don't need to use bytes, you can use bits. So here's I'll just show you how you can get around that. So we have an array of 3 32-bit unsigned thingies, and then you need to get those values into here, and how you can do that is manually, which isn't such a good idea. So if you spread everything out, and then at the end you go like that, and then you get the hex values of that. So that's 3, and then for the next group of 4, 1 and 8, so you go 3, 1, 8, and you do it all the way down, but I won't because I've already done it. So if we copy that lot, and my computer is going mad, I don't know why, I think it's RecMaster that's doing it, or Windows updates or something. Right, there we go, you've got all the hex values for that, and then what you want to do next is you take those into groups of 8, like 318, 7BC, 7F, and you put it into there. And as luck would have it, I've already done it. Copy. Paste. And apart from that, you, instead of the matrix render, you have matrix load frame. and try running that. Yeah, there we go. But that is laborious, to say the least. So what you can do is you can use this LED matrix editor. So if you draw in what you want, like that and like that, this is why I used a very simple design. There. You can press that button and it will export it for you. I won't bother to do it because I've got lots of copies of it. And then you get something that you can open in Notepad, and it looks like that. That isn't the right one, that's something different, but it doesn't matter. But that's what you get. But you don't really want that. So if you press that button, you can give it a name, and you get something that looks like, again opened in Notepad, like that. And you can just put all those numbers into your program. So I prefer to clean it up a bit, like I find it easier to visualize. And now what you can do is you can take that and paste it into your program. There. Or, well, yeah, you have to change it then. Or you can create a .h file, like a new tab, call it something like heart.h, save it, and then you need to remember to include up here, include heart.h. That's another way of doing it. But my favourite way, because I wrote it, is to do something else. So we don't need the values in there. Come on, get rid of that. And I've written a little thing that will convert the bitmap to that bitmap to that. So we go down here. Is that right? Yes, hopefully that ought to work. And you have to work your way through it. I won't explain it all. Will that work? Yep, that's another way of doing it. And just as an aside, if you want to see what's in your that array, you can print it out. But if you want to make it look like your heart, I'll take all that lot. This is very shonky code, I apologise for it. You need to have all your leading zeros and things, so I think if I put it in there, that ought to work. So that means that as you're printing out all those values, you're printing out the leading zeros, and then when you get to the end of your first 32, you need to join, you don't want a new line, otherwise it will go peculiar, but if you're interested you can look in that at my code, but it isn't the best, I have to say. Now hopefully that will work. Right, I need to reset it because it didn't print it out in time. There we go. it, right, you've got 2 and then 3 spaces, 2 and then 4, 4, 4. Yeah, that looks perfect. Now that was all just a preamble to my demo, which will be a lot more interesting. Now that we've got the boring bit, which was all about converting bitmaps to these arrays of 32 bits there, we can start using them and it will be a lot more interesting. So here we have my original image, which is the heart one, and then I've got another one which is a cross, and what I'm doing is using that as a bit mask to change various values. And the easiest way to do this is to just show you what happens. So I will upload this program. There. Clear that. Oh no, it says enter choice. That's what it will have done. Right, enter choice. So I've got this loop, and at the beginning of my loop I'm using parse_int to get the choice, which isn't ideal because it means that after you get your number, you'll get another 0 after it, so I just ignore that. So if I put in a 5, it will do it for 5, and then it will come back and say, hello, I've got a 0, so I'm just ignoring that. So I'm just showing what it does. Case 1 is to reload or load the original image, and you can't just go current image equals original image. No, it doesn't work. You have to go through the 3 occurrences, so it's the first lot of 32 bits, the second and the third. So that just loads it in, and then it loads the frame and then break. So we'll just try that. Yep, that works. Then case 2 is turning all the LEDs off, and this is where it is really useful to have it as a number, you know, like 3 hexadecimal numbers, and you can do it with this bitwise not. So you go for everything, you know, for those 3 occurrences, you turn everything to not naught, which of course is 1, which hopefully would do it. Yeah, everything on, and everything off is more simple because you're turning everything to 0 with the bitwise. No, not the bitwise. You don't use the bitwise not, just the 0. So there we go. Toggle all LEDs. Again, you're going through. Stop it. You're using your bitwise not on the current image, all the bits in the 3 occurrences, and it will turn everything. You'll toggle everything. So I turn it on, you know, the heart, and there, that ought to toggle. Toggle is like anything. Pressing 4. Case 5. What does case 5? Oh, this is turning on an LED by using the row and the column, which is slightly complicated by the fact that you have to work out in your array of 96 bits where you want to be. So if it's row 3, you have to multiply that by 12, and then add the column, and then that's your cell. And then your cell, you think, right, I need to find out which occurrence of the image it's in. So you divide by 32, which means you get a value of 0, 1 or 2. But the complicated bit is you now think, right, I'm on the 18th bit in that occurrence, which is great, but BitWrite takes it from the right hand side, not from the left hand side, which is why you have to have this 31 minus that, which is a bit confusing. I had to do it longhand and then I managed to get it to work out like that. So that ought to be turning on the LED on row 3, column 7. So we'll see, that's 5. Will that work? Yep, it works like anything. I've hard coded in those numbers because it was too much hard work to kind of say, okay, if you're on case 5, what row do you want, what column do you want? And then case 6 is doing exactly the same thing, only it's turning something off. So 6, there, turned it off at the top. And case 7, oh, I forgot, did I? Oh yes, and all I do for this BitWrite is there's the value. So if you want it on, it's a 1. If it's off, you want a 0. Then if you toggle, this is slightly more complicated, because what you have to do is if you're toggling a certain thing, you've got where you want it to be, as in that occurrence, which is 0, 1 or 2, and then you've got how many it is from the right hand end of it. Then you have to set that with the value of that, which is just reading the same thing and knotting it. But strangely, you have to use a knot with a, like that, not the squiggly, which was a knot for when you're doing for all the bits. Very confusing, very confusing. So we'll try that, which was 7. What would that do? I mean, this is just a demo of what you can do when you have dispensed with using bitmaps. So 7, right, that's the one at the bottom, and you can turn it on and turn it off and turn it on and turn it off. Right, where are we going now? Scrolling. Scrolling was very difficult, so I will go into scrolling a bit later. So you can scroll right, you can scroll left, up and down. So oh, and stop scrolling. Right, here you can turn on specific LEDs using the mask, so it's easiest to show when there isn't anything there yet. So if I go 3, which clears everything, right, then if I go on 13, which is using my mask, that is what my mask looks like. And what that does, it turns on everything using that mask. So again, you're going through the first group of 32, the second group of 32, and the third group of 32, and then so that's the first group of the current image. You then OR it with the mask image. So if the mask image bit is on, it will turn it on. If it isn't, it won't turn it on. And it doesn't matter whether it's originally on or it's off, it will always turn on, which is what the OR does. So if we try showing what happens if you've got the heart there, then you go 1 and then you do the 13. Right, that's a bit of a mess, but you can see the cross is superimposed on the heart. Right, 14 is turn off specific LEDs using the mask. And what that does is it takes, for each bit in the current image, it does an and not, which is confusing bitwise. So if the mask is a 1, it will and the current image with a not 1, which means that it will always turn off everything on that cross, whether it was on or off or anything. So if I do 14, that will get rid of the cross, but it hasn't just got rid of what I put on, it's got rid of bits of the heart as well. It's slightly confusing. So if I turn everything on like that, then if I use this one, case 14, which is turn off everything of the mask, yeah, there we go, that works wonderfully. Toggle specific LEDs using the mask. Again, we're going through all the bits of the current image, and it's doing an XOR with the image, which means if it was on, if that's a 0 and you do an XOR with a 0, it doesn't do anything. If you have a 0 and a 1, it will turn it on, so that's toggled it. If you have a 1 and a 0, it doesn't do anything. And if you have a 1 and a 1, it will turn it off, which is what an XOR does. So that means anything in the mask will be toggled, I hope. Right, shall we? Oh, I'll just try 15. Yeah, so I turned everything off that was already off, and then I turned everything on, so it goes like that. And if we go back to that, then you can do it again, and yeah. But in this case, if you toggle, if you take the heart and you toggle with the mask, and then you toggle with the mask, it will come back to the original. It's all pretty jolly good. I mean, this is just a stupid demonstration of what you can do, and I would just stop there and show you something to do with animations in a minute. Now, in order to be able to scroll the image, I need to create an animation for each scrolling thingy. Now, an animation is just displaying different screens in sequence. So here's an example from the documentation of a kind of animation of sorts. And all you do is you've got an image there and an image there, and you load one of them, you delay, you load the other one. So we'll have a look at that. There we go, it's animated. But the trouble with that is those delays. It means that that is all that your Arduino is doing. It cannot do anything else because everything's totally blocked. So if we look at the documentation, here we go. It was just saying up there about the sample images that you could display, or here are animations. And to display an animation, all you need to do is you load the sequence of whatever is in there. Well, you know what I'm aiming for, and then you just go strange, I would have put begin above there, doesn't matter, and then you play the animation, but that is using the available animations down here. Dum, 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 dum. I don't want to use their samples, so if we go down a bit more, it says animation generation. We have developed a tool that is used to generate frames and animations to be rendered on the LED matrix. Well, that happens to be this lovely LED matrix editor. So I will just create an animation, and then I'll see what I need to do when I make my own. So I rather like, because it's easy to draw, something like a battery charger. So there's the battery, and that number there, 200, I think it defaults to 66, which is a bit fast. So 200, that's the delay between each screen, and you press there and it creates another frame, and you can add something, and then again add something. And it's always best to get your delay right in the beginning, because otherwise you have to change every one. Doing, doing, doing. Right, so we go there, like that, there, like that, and then, well, if I go back there, then you can play it. Wonderful. That's what it will do. So pressing that button up there, that one there, means you can save it. So I will just put, I'd call it charging. I called it charging before, so it will do all sorts of shenanigans. Right. Oh, yet another charging, it says. So we have a look at this, and I don't know what that opens it with. So if I go onto File Manager, right, open that with Notepad. Right, again, it's done all this thing. I want to get an idea of what it's doing. I don't know if you can hear my stupid computer. It's very annoying. Right, to get an idea of what it's doing, what I need to create is something like that, which is for every line. I'll actually get rid of all of those rather than have to, whoops, rather than have to edit it all. Delete that. Right, so this is just a sample. All the line, oh, for goodness sake, look. Copy, paste, 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 paste. That is what I'm aiming for. So I've just got the screen I want to, the image I want to display, and then 200, then 200. So this is what I'm aiming for. So I will show how I did it in my program. Now, before I go back to my program, I just want to show you a trap that I fell into. So I'll just quickly, as quickly as I possibly can, I'll draw my heart again. There, and then I next frame, and if you press up arrow, shift up arrow, it will move everything up, and then next frame, shift up arrow, next frame, shift up arrow, next frame, shift up. Going as fast as I can. There. Now we've got 1, 2, 3, 4, 5, 6, 7, 8 frames. And if you play that, it does everything as you'd want it to. The heart goes back to its original position, so you think that's great. So to demonstrate the problem, I've written a little program, and I've just taken all the code from the editor and put it in that bit, and I'm doing what my program would do. So it initially displays the current image, the heart, which is there, and then it waits a bit, and then it does the scrolling. So there we go, load that in, delay for a bit, and play that. And if we upload that, there, heart, scroll up, and it's scrolling marvellously, which is wonderful. But you don't have to keep scrolling forever. You can just do it once. So if I try that, upload it, sorry, you get rid of the true. If you get rid of the true, it will only play once. So here we go, it's displaying the original heart. Yep, it's scrolling once and then it's stopping, and I thought, that isn't great. And it means that if you're doing where's the LED thingy? There. So you've got 1, 2, 3, 4, 5, 6, 7, 8. You don't want to be tempted to put another. You don't want to be tempted to put that one, so you have 9, because that would create a stutter when you're doing the continuous scroll. So the way to sort that out is to put the original image in the last position there, and then it will display the original image. Then it will scroll through that, and it means when it stops, it will be in the right position. So I just thought I would show that. So really what I was doing in the editor was, when I made a new frame and then pressed shift up arrow, it shifted all the bits by 12 to the left, and that's what you really want to do in your program. But unfortunately you don't have one long 96-bit thingy. It's divided into 32, it's 3 times 32. So if you shift 1 to 12 to the left, you lose some. I will explain what you do. So if you go through and you do a shift to the left by 12, then that's the original, and then that's the new one. So what you're doing is you are putting that there. If you do your shift to the left by 12, and you put that there, and you put that there, but then you've got a big gap there. So what you have to do is you have to put that into there, that into there, and then that into there. And that's what I'm wanting to do in my program. So I thought it was easier to show it like that rather than try and explain. So program coming up. So I really won't be able to explain this very well at all. So I've got that, which is what I'm using to store the 8 frames that I need for vertical scrolling, and I've also got the scroll delay there. And we come down to here, yeah, scroll up, and that bit there is when I'm saving the current image in the last frame of, as I said before, it needs to be in the last frame of the sequence. And then here it's just horrendous with all the indices for everything, but that bit there is when I take the original first group, shift 12 to the left and put it in there, and that's what that bit does. Then the next bit, that bit there, is when I go on to the next group, I shift everything 20 to the right, so it means I'm just left with 12 bits there, and then it's right justified, so when I OR it, it goes in there. So if you OR that and that, it's kind of like the equivalent of doing a plus, but not as efficient. A plus wouldn't be as efficient. You're doing an OR, and then you go through everything. So if you're interested, you can just use that. You don't have to worry about whether it works or whether you understand it, because it does work, and if you can't understand it, then so what. But I thought it was quite interesting that you could do it like that. So if we run this and see whether it actually works, don't want that. Reflection there, that ought to be work. So if I just run this program, we'll upload it, which then of course we'll run it. There. So if I display the heart there, and then I go on to what was it, 10, and I do 10, and there we go. That bit of code, in fact it's just a one-liner, isn't it? That one-liner has scrolled it, and I can stop it if I wish. Stop. When I want to stop it, it's very easy. You just load in the current image and it will stop everything scrolling, which is quite handy. And if I change, just to prove that it does work, my line's too long, I will miss up the end. Right, go back here. Thank you. Go back here. If I change that, get rid of the true, hopefully when I upload it, it will just scroll once and it will end up in the right place. There we go. 1, and it was 10, wasn't it? 10. There, and it's in the original place, which is great. Now, to prove that it isn't just doing it with that, is it 4 to invert? I can't remember. Yeah, 4 to invert. You can do the same thing. So if you invert it and then you try scrolling that, there, works like anything. And I'll put this back to true because that's better. And where's the mask? You can show it with a mask. 13. Right, so if I just go 13, there we've got the cross, and hopefully that can scroll. Yep, that scrolls like anything, but I'll turn that off because it's annoying. Right, so that's scrolling up. Scrolling down is very, very similar. In fact, apart from all the indices, it's exactly the same, but I've got them in reverse order. I've done all sorts of jiggery pokery. I mean, the only way you can understand, I mean, that is just about the same, only it means that instead of the next image using the one above, you use the one below in the frame, if you get my drift. Because, well, if you can understand case 10, you can understand case 11. So, what shall we do? Can't remember what it was. Oh, we'll just go that. No, I didn't want to do that. I've just typed in my program. Oh, Z. Yeah, I just deleted the all-important line. Right, so if we put the heart back, and then it's 11 to scroll down. There, that works. That works wonderfully. And you don't need to stop it before you scroll up. So that's all to do with scrolling vertically. Right, so now I'm going on to scrolling to the left. And the easiest way to start this is just to shift everything by 1 bit to the left, which would be easy if it was a 96-bit thingy, but you have to do it individually in lots of 3. So here we go. I'll try not to overwrite it. So you move by shifting by 1, that goes to there, and that goes to there. Sorry, that's original, that's new, and that goes to there. And what you've done is you've now dropped off the first digit, bit even, and you've got a somewhere you haven't put anything in there. That would be a 0, one would imagine, but you need to do something with it. And as you can see, as it's all one continuous thing, all you have to do is move that one from the original into there, and that one into the original there, and that one's missing as well, but you don't have to worry about that because it will be taken care of in a minute. So we're nearly there, I think. Now we have to consider each individual row, so that's 12 bits and that's 12 bits, and what has happened from doing what we did up there is that we've dropped off the first digit, the first bit of that, so the original goes in there, which is what you want to do. When you're scrolling, you move everything to the left, you drop the first one, and then you put the first one back on. So that's all we need to do. We need to go through every row and move from the original to there, and then everything ought to be wonderful. So see what it looks like in the program. Right, so I'll just show how I did this in my program. I needed to have 12 frames because I'm shifting 12 times, and I've got the delay there. And if we come down here, right, case 8, which was scroll left. As before, I've put the current image in the last frame of the array, and that bit there is when I'm just shifting. I'm just taking that and putting it in there, shifted to the left by 1, that to there, that to there. That's what it does. And then these 2 lines are when I'm doing the copying that bit to there and that bit to there. Now it looks a little confusing because with a bit read and a bit write, you're reading from the right, so that's 0, 1, 2, 3, 4, 5. So that is why you're moving 31, because that's the 31st from the right to the north. Then this bit, I originally was copying one bit to another from the new frame, and then I thought it would be so much less confusing to move it, to copy from the original row, from the original frame to the new frame. So that's why I'm counting backwards, so it doesn't really make much difference. So what I'm doing is I'm looking that bit there. You just have to ignore all those awfulnesses. That is the 11th from the left, which is that one, which I'm moving to the north one there. So that line does everything. And to be honest, excuse me, if I try and explain, you either, again, if you want to use it, you can just use it, and the more I explain, the more I will confuse myself, and the more I will confuse everyone else. So I'll just try running this. So here I'm just going to prove that it does work. Reset it. 1 displays that. Then what was it? Oh, 8. There we go. It's scrolling like anything, and I can even, while it's scrolling, I can do that. So it turns to scrolling up or scrolling down, and the scrolling to the right is exactly the same as scrolling to the left, only I've put the frames in different order. But I won't bother to explain any of that because it's too boring. So this program was just to show that you could do more than just using a bitmap, because it's fun. And once you've written it, you don't have to worry about it. You just use it. So any comments would be appreciated.